Welcome everyone. So we will be discussing Indian contribution to science. This is a book which is compiled by Vigyan Bharati, and this is one of the chapters which is there for the VVM examination.
15. Traditional wisdom of astronomy. Development of astronomy in India has come a long way since the Vedic times, and now ISRO heads our space exploration and research in astronomy. When mentioning Indian astronomy, an image that automatically comes to our mind is that of Jantar Mantar. It was built by Savai Jai Singh of Jaipur in 18th century. These collections of huge instruments for astronomical observations were fundamentally based on ancient India's astronomy text. 5 Jantar Mantars were built to revise the calendars and make a more accurate collection of tables that could predict the motions of the major stars and planets. This data was to be used for more accurate time measurement, improved predictions of eclipses, and better tracking of positions of stars and planets with relation to the Earth. They are so large in scale that is supposed to have been aimed at increasing their accuracy. In Jantar Mantar, one can find the world's largest sundial and literally see the sun's shadow move every second. Records also show that telescopes were built and used in certain observations. This kind of accuracy helped produce in those ages some remarkably accurate results which even contemporary Europeans could not beat. One important lesson to learn from Jantar Mantar is that the Raja built 5 of them. He could have built just one and been happy with the results. He built 5 so that results given by one observatory could be verified against those of another. This kind of verifications obviously reduce the human error involved when taking readings on an instrument. Also, 5 observatories were in 5 different cities. Thus, one could check the position reading of heavenly bodies from different parts of the earth and again verify the overall results. This shows a strong display of scientific inquiry method in the minds of our past astronomers. The idea behind Jantar Mantar came from the ancient Indian texts written by Aryabhatta, Varamihira, Bhaskaracharya, and others. The most important text of ancient India, astronomy, has been compiled between the 5th and the 15th century CE, the classical era of Indian astronomy. The more familiar ones among these works are Aryabhatiya, Aryabhata Siddhanta, Pancha Siddhantika, and Laghu Bhaskaryam. Ancient India astronomers were notably in several respects. Their achievements are even more baffling considering they never used any kind of telescopes. They put forth the sun centric theory for the solar system, elliptical orbits for planets instead of circular ones, reasonably accurate calculations for the length of a year and the earth dimension, and the idea that our sun was no different from the countless other stars in the night sky. So, here is a picture. We can see here is a picture of Jaipur Nadi Wolf Yantra, which tells us the sun's hemispheric position. So, this is what is the hemispheric position of the sun that was given in those days. Somewhere during the Middle Ages, progress in the fields of astronomy stood still, and an admixture of astronomy and astrology arose. With colonization, the European school of astronomy displayed our own. The last remarkable astronomer in pre-independence India was Samanta Chandrasekhara. His book Siddhant Darpana and his use of simple instruments in getting accurate observation earned him praise even from the British. In our present era, the Indian space program stands on the contributions made by two giants in the field of physics Homi J. Bhabha, and Vikram Sarabhai. It was their tireless efforts which initiated work in space research under the Department of Atomic Energy. Over this period of time, India also produced some remarkable astronomers and astrophysicists. Meghnad Shah and Subramanian Chandrasekhar are two world renowned names in astrophysics. On the side of the observational astronomy, we had Dr. M.K. Vainu Bapu, till date the only Indian to have a comet named after him or her. Currently, the Giant Meter Wave Radio Telescope GMRT at Kodad near Pune is the largest of its kind in the world. The Kavalur Observatory, named after Dr. Bapu, is one of the best equipped in eastern hemisphere. So here you can see the Kavalur Observatory, and here the partial solar eclipse images which was taken at the VBO Kavalur. Jantar Mantar, ancient astronomical observatories of India and some instruments. Historically, Indian astronomy developed as a discipline of Vedanga, or one of the auxiliary disciplines associated with study of the Vedas. The oldest known text is the Vedanga Jyotisha, dated between 1400 to 1200 BC. Indian astronomy was in its peak in the 5th 6th centuries, with Aryabhatta and his Aryabhatiya representing the pinnacle of astronomical knowledge. Later, Indian astronomy influenced Muslim astronomy, Chinese astronomy, European astronomy, and others significantly. Other astronomers of the classical era who further elaborated on Aryabhatta's work include Brahmagupta, Varahamihira, and Lalla. An identifiable astronomical tradition remained active throughout the medieval period and into the 18th century, especially with Kerala school of astronomy and mathematics founded by Sangamagrama Madhava, 1350 to 1425 AD, of Irijalakkuda in Kerala. The classical era of Indian astronomy begins in the late Gupta era, the 5th to 6th century. The Panchasiddhantika, that is Varahamihira, written by Varahamihira 505 CE, approximates the method of determination of the meridian direction from any three positions of the shadow using Namon or Sanku. Once, while visiting the court of Emperor Muhammad Shah, Maharaja Jai Singh II of Jaipur overheard a loud argument about how to calculate the most astronomically advantageous date for the purpose of the emperor's beginning a journey. To the Maharaja, the debate highlighted the need for education in the field of astronomy and for an observatory that could make accurate astronomical calculations. The idea for Jantar Mantar, or calculation instrument, was born. Jantar Mantar consists of a number of structures in stone, brick, and marble, each of them marked with astronomical scales and designed to serve a specific purpose. Of the observatories originally built in Delhi, Jaipur, Mathura, Ujjain, and Varanasi, all the observatories still exist except one in Mathura. Among the devices used for astronomy was gnomon, known as Sanku, in which the shadow of the vertical rod is applied to on a horizontal plane in order to ascertain the cardinal directions, the latitude of the point of observations, and the time of observation. This device finds mention in the works of Varamihira, Aryabhatta, Bhaskara, Brahmagupta, among others. The armillary spear was used for observation in India since early times and finds mention in the works of Aryabhatta 476 CE. The Goladipika, a detailed treatise dealing with globes and the armillary spheres are composed between 1380 to 1460 CE by Parameshwara. Probably the celestial coordinates of the junction stars of the lunar mansion were determined by the armillary since the 17th century. There was also a celestial globe rotated by flowing water. The seamless celestial globe invented in Mughal India, especially in Lahore and Kashmir, is considered to be one of the most impressive astronomical instruments and remarkable feats in metallurgy and engineering. All globes before and after this were seamed and in the 20th century creating a seamless metal globe was believed by metallurgists to be technically impossible even with modern technology. Lagu Samrat Yantra in Jaipur. The small sundial or Laghu Samrat Yantra is the instrument used for time calculation. From one side, the wall is inclined at an angle of 27 degrees, which is equivalent to the latitude of Jaipur. It is graduated to the scale of the tangent to find out the declination angle of the sun. Next, we have Samrat Yantra. The Samrat Yantra was described as gigantic sundial. Literally, it means king of all the instruments. It is not only the biggest of all the yantras, but it is the most extraordinary in accuracy and excellence in construction. Next, we have Rashi Valaya, that is star sign. It is a group of 12 instruments with graduated quadrants on both the sides as mentioned in books. The purpose of constructing the 12 instruments was to get the direct determination of celestial latitude and longitude. The method of observing celestial latitude and longitude is precisely the same as that described for Samrat Yantra, and just as the quadrant of the later represents the equator, so also the quadrants of Rashi Valaya represents the ecliptic at the moment of observation. The instruments are constructed in such scientific way that one of these 12 is used at the moment when each sign of the zodiac reaches the local meridian. Next we have Ram Yantra. Ram Yantra measures the altitude of the sun according to the height of the shadow cast by the gnomon, the dark upright pole at the center right. In this photo, the reflected glare from the sun has washed out the scale grid in the central section. It is more visible on upright section or to the left and right. As the sun rises and falls, the shadow falls and rises correspondingly, moving around the instrument. Next we have Mishra Yantra. Delhi Observatory has one feature, the Mishra Yantra, which is not included at any other sites. In fact, this is the only part of Jantar Mantar structure that was not created by Jai Singh II. The Mishra Yantra is thought to have been added by Jai Singh II's son, Maharaja Madho Singh, who continued his father's effort towards modernization. 5 separate instruments make up the Mishra Yantra, including a smaller scale Samrat or sundial. 2 pillars adjoining the Mishra Yantra indicate the year's shortest and the longest days. The giant device could also show when it was noon in a number of cities around the world. Next, some of the great ancient Indian astronomers. First one we have Laghada, that is first millennium BC. He had written the earliest astronomical text Vedanga Jyotika, which provides details on several astronomical attributes generally applied for the timing, social, and religious events. It also explains astronomical calculations and calendar studies and establishes rules for empirical observations. Vedanga Jyotika has connections with Indian astronomy and mentions important aspects of the time and seasons, including lunar months, solar months, and their adjustment by the lunar leap month of Adimasa. Ritus and yugas are also described. It also mentions 27 constellations, eclipses, 7 planets, and 12 signs of zodiac known at that time. Next, we have Aryabhatta 476 to 550 CE. Aryabhatta was the author of Aryabhatya and the Aryabhati Siddhanta. Aryabhatta explicitly mentioned that the earth rotates about its axis, thereby causing what appears to be an apparent westward motion of the stars. Aryabhatta also mentioned that reflected sunlight is the cause behind the shining of the moon. Aryabhatta followers were particularly strong in South India, where his principles of diurnal rotation of the earth, among others, were followed, and a number of secondary work were based on them. Next, we have Brahmagupta from 598 to 668 CE. His Brahmasputa Siddhanta correctly established doctrine of Brahma 628 CE dealt with both Indian mathematics and astronomy. Brahmagupta also calculated the instantaneous motion of a planet, gave correct equation for parallax and computation of eclipses. His works introduced the Indian concept of mathematics based astronomy into the Arab world. He also theorized that all bodies with mass are attracted to the earth. Varamihira 505 CE. Varamihira was an astronomer and a mathematician who studied Indian astronomy as well as many principles of Greek, Egyptian, and Roman astronomical sciences. His Panchasiddhantika is a treatise and compendium drawing from several sources. Bhaskara 1, 629 CE. His work on astronomy are Mahabhaskarya, Laghu Bhaskariya, and Arya, Aryabhat, Aryabhatya Bhasya. 629 CE, a contemporary of the Aryabhatya. Bhaskara devised methods for determining the parallax in longitude directly, the motion of equinoxes and solstices, and the quadrants of the sun at the given time. Next, we have Lalla, 8th century CE. His work, Uisya, Uisyadhi Vridhida, corrects several assumptions of Aryabhatya. The Sisyadhir Vidida of Lalla deals with the planetary calculations, determination of the mean and true planets, three problems pertaining to diurnal motion of Earth, eclipses, rising and setting of the planets, various cusps of moon, planetary and astral conjunctions, and complementary situations of the sun and the moon. The second part, titled Goladhyay, chapter 14 to chapter 22, deals with graphical representation of planetary motions, astronomical instruments, perics, and emphasizes on corrections of rejections of flawed principles. Lalla also authored the Siddhanta Tilaka. Bhaskara 2, 1114 CE. His two works are Siddhanta Siromani and Karana Kutuhala, Calculations of Astronomical Wonders. He reported his observations of planetary positions, conjunctions, eclipses, cosmography, geography, mathematics, and astronomical equipments used in several research of at the observatory in Ujjain, which he headed. Sripati 1045 CE. Sripati was an astronomer and mathematician who followed Brahmagupta school and wrote Siddhanta Shekhara, the crest of established doctrines, in 20 chapters, thereby introducing several new concepts, including moon second inequality. Mahendra Suri, 14th century CE, Mahendra Suri authored the Yantra Raja, the King of Instruments, written in 1370 CE, a Sanskrit work of astrolabe which was introduced in India during the reign of 14th century Tughlaq dynasty ruler Firuz Shah Tughlaq. Suri seems to have been a Jain astronomer in the service of Firuz Shah Tughlaq. Next, we have Nilakantha Somyaji, that is 1444 to 1544 CE. In 1500, Nilakanthan Somyaji of the Kerala School of Astronomy and Mathematics, in his Tantra Sangraha, revised Aryabhatta's model for planets Mercury and Venus. His equation of the center for these planets remained the most accurate until the time of Johannes Kepler in 17th century. Nilakantha Somyaji, in his Aryabhatya Bhasya, a complementary of Aryabhatta's Aryabhatya, developed his own computational system for a partial heliocentric planetary models in which Mercury, Venus, Mars, Jupiter, and Saturn orbit the Sun, which in turn orbits the Earth. He also authored a treatise titled Jyotirmimamsa, stressing the necessity and importance of astronomical observations to obtain correct parameters for computation. At the last, we have Achyuta Pisaradi, that is 1550 to 1621 CE. His work Sputarnirnaya, determination of true planets, details and elliptical corrections to existing notions. Sputarnirnaya was later expanded to Rasigola Sputarniti, true longitude computation of sphere of the zodiac. Another work of Achyuta Pisaradi, Karanottama, deals with eclipses, complementary relationships between the sun and the moon, the deviations of the mean, and the true planets in Uparaga Kriya Karma, methods of computing eclipses. Achyuta Pisaradi suggests improvements in methods of calculations and eclipses. Thank you.